Okay, lesson 78, force vectors on a point. Let's just get into example 1. Two ropes are attached to a point and pulled on with the direction and magnitude shown. What is the resultant force? So what we have here is a point, and at the point we're pulling a rope at 45 degrees with a force of 70. We can change velocity to represent force, the vectors to represent force. So instead of this being 70 long, the vectors, it's going to be the force of 70. So we have a force of 70 pulling at a 45 degree angle, and over here we have a force of 40 pulling at that point at a 30 degree angle. We want to find the resultant force. So what we're trying to find is if we had one rope pulling at this point, what degree and what force would we have to pull that one single rope to get the same force as these two ropes pulling in opposite directions. So the first thing I want to do is change these into triangles. You could either drop your lines here to make them into triangles, or I redrew them as triangles. And I already have some things written in just to make it a little bit faster. So I redrew the triangles, and we're going to try to find our x value and our y value. Remember, your y value is going to be your sine because it's opposite over hypotenuse. Your x value is your cosine because it's adjacent to 45. So hopefully you get this, and this is just review for you, the first part of this. So I set this up already. Y equals 70 sine of 45 degrees. I also have to erase something. I'll just erase these. I'm going to write these in as we go. Sorry about that. Okay, so we know that y equals 70 sine of 45 degrees, and that's 49.497, and x is 70 cosine of 45 degrees, and that would be 49.497. And just to note, in case you haven't noticed it yet, sine of 45 and cosine of 45 degrees are both the same. They're square root of 2 over 2. So these will always be the same if you have 45 degrees. Okay, let's go over here and get y. Y prime is opposite, so it's going to be 40 sine of 30 degrees, and that's going to be 20. And x prime is 40 cosine of 30 degrees, and that's going to be 34.64. So we're going to add our left-right forces together, and we're going to add our up forces together, and that's going to give us our resultant force. So let's just do that here. Let's do our left-right force first. So our x is our left-right, and if you notice, the x is pulled to the left. Even when I made the point where this point that we're trying to find, it's a negative x coordinate. So when we're adding our left-right forces together, keep in mind that this is our left-right forces, our x. This is going to be a negative. So this would be our left-right. Our negative would be negative 49.497. And then this force is going to go to the right, so it's going to be positive, and it's going to be 34.64. So the total left-right force, if I add our two x values together, is going to be negative 14.86 right. Then we're just going to add our up forces. We don't have any down forces, so it's going to be 49.497. They're both going up, so they're both going to be positive. Plus 20 is going to give us a 69.497 up. So the coordinate of the point that is going to, where our rope is going to go, our one rope is going to be negative 14.86 right plus 69.50 up. Now we do have to translate these back into polar form so that we have a force and a direction. So I'm going to plot that point. This is how you can do this. I'm going to plot that. negative 14.86, and then 69. So you just estimate it. You don't have to do a serious graph here. But it is going to be higher because this is a lot bigger than 14 than it is wider at the bottom. So this is going to be 14.86 to the left, and then up 69.50. Unfortunately, to get the hypotenuse, or our magnitude, or our force, we need to use the Pythagorean theorem to do that. So our force, this is our vector length, is going to be 69.5 squared plus 14.86 squared, and then we take the square root of it, because the Pythagorean theorem is this squared plus this squared equals the hypotenuse squared, and then we take the square root of it. So our force, fortunately we have calculators nowadays, so this isn't too bad, is 5,051, or our force is approximately 71.07. So that would be our force right there. It's approximately 71.07. Now, the only thing we need to put in polar form is we need our angle. So to do the angle, we always use tangent. So we use the tangent of theta equals opposite, which is 69.50, over adjacent, which is 14.86. And that comes out to be 4.6770. But we want theta, so we're going to take the inverse tangent to get theta. So the inverse tangent of 4.6770 equals theta. And we just plug that straight into our calculator. So we're going to get theta equals 77.93 degrees. So if we pulled on the rope at a force of 71.0 at 77.93 degrees, the same force will be acted upon the point as if the two ropes were pulling on it. So finally you have to write this in vector form, in polar form. So it would be 71.07 at 100 and, whoops, and then I didn't quite finish it up yet. This right here is 77.93 degrees. We want this angle right here. That angle is right there. So that's going to be 180 minus our 77.93 to give us this angle right here. And that's going to be 102.07 degrees. And that's what we're going to put in here, 102.07 degrees. So there's a lot to take in with this problem. If at any point you got lost in doing problems with vectors, then this might be difficult. So let me know in class on Thursday if this is these problems. We can all actually do one of these in class if we need to. Okay, let's try one more example of these. This is rather long. These problems are long. Okay, this one's a little bit more simple though. Here a point is acted on by a push force and a pull force is shown. Find the resultant force on the point. So this one's being pushed at a force of 10, and it's being pulled at a force of 16 at 30 degrees. So we want to find the resultant force. This is just a horizontal force. This one we need to make a triangle. So let's first of all make ourselves a triangle, and we'll call this Y and this X. Let's find our Y and X of this one first. So here we go. To get Y, it's going to be 16 sine of 30 degrees, which ends up being 8, because the sine of 30 is always 1/2. And then our X is going to be 16 cosine of 30 degrees, which doesn't end up being quite as nice, and that's 13.86. Now let's look at this. It's just a horizontal force. So this one, our X coordinate, is going to the right, so our X coordinate, we'll call that X prime. Our X coordinate is just going to be 10. And our y-coordinate, since it's not going up and down at all, is just going to be 0. So we're just going to add those together. So this would be, our y-coordinate would be 8 up. Our x-coordinate is 13.86 right. This is going to be a right as well, and this is our up. So if we add our ups together, we're going to have our y-coordinates added together would just be 8 up. I should add my rights together first. And then our right, I should line these up a little bit more, would have been 10 plus 13.86, which is going to be 23.86 right. And then finally we're going to find our resultant force. So if you plotted that, you would go, I like to do this whole diagram, and you don't have to do. We're going to go right 23.86 and up 8. So it's going to look like this, but not quite. It's not very good at scale. This is 8 up. So we have to use the Pythagorean theorem again to get this force right here, and we need to find theta. Bear with me, I know this is hard to watch on a video. I wouldn't want to be watching this right now. So you get, using the Pythagorean theorem, we're going to get our force, call that F. So our force is equal to 23.86 squared plus 8 squared, and then we would take the square root of it. So our force is 25.17. And then to find theta, we say the tangent of theta equals opposite over adjacent, and that would equal 0.335, and our inverse tangent of 0.335 gives us our degree, which is 18.54 degrees. And since we're going from here up to here, we don't have to add or subtract it from 180 or anything. We just write it in fuller form. Our force, our resultant force, that we would have to pull in that point to get the same force as those two ropes, would be 25.17 at 18.54 degrees. So it's a little bit more difficult of a lesson, and well, I'm happy to go over with this on Thursday with you if you're stuck. So that's it for lesson 78.